Good morning, good afternoon, good evening to you, wherever you're joining us from, and welcome to this webinar hosted by Wevolver and Quest Global. Um, we can see some people joining us already, so we'll give it a couple of minutes as we go through this. But allow me first to introduce Wevolver to you if this is the first time you've joined webinars from Wevolver. So Wevolver is a global platform and community used by engineers to stay up to date about the latest technologies. And on Wevolver, professional engineers access informative and inspiring content such as articles, videos, and webinars like today, basically, on content or on topics like robotics, aerospace, advanced manufacturing, AI, and state-of-the-art technologies. And every month, millions of engineers leverage Revolver to stay up to date, find knowledge when they are developing products, and make meaningful connections with each other and the industry. So, in a nutshell, Revolver is how today's engineers stay cutting edge. Now, with us today is Quest Global. And Quest Global started in the year 1997, and today it operates across 17 countries with 68 global delivery centers and offices and driven by over 20,000 extraordinary employees, solving the most critical and large-scale customer challenges across the aerospace and defense industry, the automotive industry, energy industry, high tech, med tech, and healthcare, all the way to rail, semiconductor, and communications industry. So we're really excited to have Quest Global with us today. If this is the first time you guys are joining a Wevolver webinar, just some quick housekeeping. First of all, feel free to introduce yourself in the chat. And as we go through the webinar with our panel, do put your questions and comments there as well. We'll make sure to get to them towards the end of discussion in a nice Q&A session as well. Now, one question that we get a lot in these webinars is whether the webinar is recorded. Of course it is, but we do recommend that you stay with us throughout the discussion so you can be part of it, communicate with our panel live, and get all the information that you need. Now, today's webinar brings you insights about unlocking the potential of digital twins and digital threads for aerospace and defense manufacturing. And I'm really excited to hear from our panelists about all this over the next, say, 45 minutes or so. So without further ado, let's meet our panel. First, we have Mr. Nick Charles. Nick is the head of engineering for UK Defense at Quest Global and a seasoned engineering leader with extensive experience in the aerospace and defense sectors. Nick previously served as VP and Senior VP at Ultra Maritime, leading a team of over 800 engineers across 5 countries. And Nick was responsible for challenging engineering projects and drove major improvements in engineering processes, team development, and risk management. So Nick, thank you very much for being here.
Thank you.
Also, we have Vijay Anand. So Vijay is the head of Advanced Manufacturing Center of Excellence at Quest Global, based out of Derby, UK. And Vijay is a veteran of manufacturing engineering for over 30 years, both in traditional and digital manufacturing. And he's heavily influenced by the Toyota way of working and embraced the same in his roles at Quest Global while managing a global manufacturing team and solutions for major aerospace and defense, energy, and transportation customers till today. Vijay has been instrumental in setting up a digital manufacturing lab in partnership with Siemens to design, develop, and simulate the manufacturing and assembly operations. And he also represented Quest Global in digital manufacturing focus group conferences for a major aero engine customer held at various global locations. So Vijay, pleasure to have you.
Thanks for having me, Samir.
And last but not least, we have Luke Logan. Luke is a seasoned business leader with a significant career in engineering and technology. Luke has over 3 decades of senior executive experience and has led global teams and managed major projects at Rolls-Royce, BAE Systems, and Via Group, 3 of the world's leading engineering and technology companies. And his broad expertise across sectors such as civil aerospace, defense, power, and industrial equipment enables him to share a wealth of insights and foster diversity of thought, which I'm really looking forward to hear from you, Luke, today. Now, today, Luke is an independent advisor and consultant, and he applies his extensive experience to support the growth and development of his clients' businesses. And he's deeply committed to diversity and inclusion, innovation, and aligning engineering professionalism with business success and sustainability. Luke is a fellow of the Royal Academy of Engineering, the Institute of Mechanical Engineering, and the Royal Aeronautical Society. So, Luke, very, very happy to have you as well.
Thanks, Samir, and hello to everybody on the call.
Great. So, let's dive right in. Nick, if I can go to you first. Now, a lot of people have heard of the term digital twins, right? It's been a buzzword for the past couple of years, but not a lot know what it actually is, and not a lot know what digital threads do as well. So we understand that digital threads and digital tech twins are reshaping the aerospace and defense manufacturing space today. So could you start by explaining the difference between these two technologies and how they complement each other throughout the product lifecycle?
Yeah, of course. Thank you, Samir. I'm going to start with digital threads. And because interestingly, there's no one single industry definition of what a digital thread is. Indeed, every company kind of looks at it and thinks of it differently. So I'm going to talk a bit about how Quest Global think about digital threads. And then hopefully that can relate to your experience. So our definition of digital thread is every system, data exchange, and mechanism methodology involved in the design, development, manufacture, commissioning, support of a system or product. So fundamentally, everything that you need to do from the concept of a product all the way through design, development, integration, commissioning, manufacture, support, and then ultimately decommissioning. All of those things, of course, involve many different mechanisms, tools, processes, and methodologies, often done in quite disparate, segregated, siloed, either tools, systems, or processes. So digital thread is, if you like, a kind of digital backbone or digital bus of connecting together all of those different integrated, all of those different siloed processes in an integrated, consistent, and cohesive manner, such that ultimately the process by which you're designing and developing something becomes a much more efficient, integrated mechanism. Obviously, that's a kind of ultimate panacea, and of course, you'll never ultimately get there because there's always efficiency gains to be had in each element of the product design, development, and maturity lifecycle. So it's a continually evolving and developing element for every company in what they do within core engineering. So I'd say anyone that's involved in design development of a product or system will have some elements of a digital thread involved in their core business process. By comparison, digital twin is one of those elements which is used within design development and support products. Whereas the digital thread is that very holistic end-to-end design development ecosystem. A digital twin is a virtual replica of a real-life product, process, or performance. And the intent is to, in the process I've just described, to simulate real-life scenario or scenarios of either the product, the process, the performance of that product, such that you can study, optimize, and examine the behaviors of that particular thing in a virtual environment before you actually move forward to real realization of that product or system. Obviously, that has the benefit of ultimately left shifting design and development and left shifting risk, which is a key major driver for pretty much all aerospace and defense customers. So because of the difference in nature, so digital twin is very specific to a particular product, process, or solution, whereas a digital thread is a much more generic. It could apply to across multiple different products, so you could have a very similar life cycle, the same ecosystem, designing and developing two different things, whereas a digital twin is very specific to that particular thing you're doing and making a virtual equivalent version of that in a simulated environment, and that can form there's many different elements of digital twin, all the way from the kind of obvious kind of CAD type representations all the way through to virtual shop floors or very elaborate performance modeling. So it can form many different forms depending on what your application is for your particular need.
Right. Thank you for that. That's really insightful. Luke, could I bring you in here, and could you tell us maybe look at the impact of these technologies on the industry level? Would you like to add some?
Yeah, sure. And and I should say, I guess my experience, over the 3 or 4 decades that Vijay mentioned, I guess I've seen quite a lot of change across aerospace and defense, and I guess I'm pretty excited by what the digital thread and digital twins can bring. So I'll probably just touch on a few drivers that are in my mind. I'll probably start off with saying in many ways, businesses and engineering and manufacturing functions are still under the same pressures they were at the start of my career. So quality, cost and delivery, QCD as many people call it, all those same pressures are there. But there are a few things that have changed. The world is really uncertain. It is really connected compared to where we were even 1 decade ago, yet alone 2 decades ago. And so I guess I see a couple of things emerging for business and technical leaders. One is that I think we're in such a complex system of systems connected world that actually I think humans, and certainly individual humans, no matter what title a business is given, are no longer able to assimilate all the various elements of data and information to be able to make decisions. On top of that, the pressures to make decisions quickly, whether that's because you're in the middle of an automotive production line or you're in the middle of flying fare-paying passengers over large bodies of water, or if you're in the defense sector, threats are emerging by hours, minutes and weeks now rather than over the years. And so not only is it more complex to make your decisions, but you've got less time to make them. So I see that as the primary driver that excites me about some of the benefits that can come from what Nick explained. And if I was to go probably a level down, I would say the particular challenges that you've got over the functions and the businesses now include product development timescales needing to compress significantly. And that's not just the time to engineer, but it's also how you can compress the total time with our manufacturing colleagues and then get them cleared through the regulatory cycle as well. Life cycle management is increasingly important. I certainly grew up in an era where so much of our focus was on the original equipment or the OE. We all now, and I'm sure all of us who are on the call have got experiences of where a poor OE or not particularly well validated for service original equipment or systems has cost us or cost our customers no end of problems and financial burden throughout the life cycle. So being able to kind of think about these digital twins and what they can bring from a full life cycle management perspective is particularly important. And if I could just keep the microphone for a couple more seconds, the other thing I would bring is over the last 2 or 3 years, certainly post-COVID, I think the word resilience is really in my mind. And I genuinely believe that digital twins can help all of us in personal and business life from being able to be more resilient to those emergent, uncertain things that can come our way. So being able to kind of help those leading the business and those right at the bottom of the working level part of the business, our technicians, our technologists, our supply chain partners, to be able to have some decision assist capability driven by real-time feedback, analytics, and a virtual model running alongside the physical model, I think it'll be transformational.
Really insightful. Thank you for that. Vijay, I'd like to bring you in here because, I mean, Luke was talking about these challenges, right? We talk about the industry challenges, and we often hear about the need for tighter production schedules and greater precision in A&D. So how are digital twin and digital thread technologies helping manufacturers meet these demands without compromising safety or innovation?
Yeah, so again, that's again a good continuation into what Luke alluded to with respect to the quality, cost, and delivery. These are the 3 primary metrics on which the whole world works. And as Nick told, both of these technologies are used proactively to identify problems and predict failures, which can be addressed upfront within design or in concept stage, Samir. So what happens is this improves the time to make. That again impacts the production schedule and also brings in the reliability part, which Luke was mentioning. The whole gambit of design for manufacturability, which is going to be the backbone of digital manufacturing going forward, which we often say, but we seldom practice. That is going to be the backbone for digital manufacturing and manufacturability during our new production introduction. But when moving from the new product introduction or product introduction, when we get into the industrialization phase in the life cycle, the connected digital twin, which Nick told us, the virtual replica, that will kind of beam out the real-time data along with the digital thread through various Industry 4.2 technologies like Edge, IoT, and other intuitive visual dashboards for better decision making. Thereby, it improves production efficiency, and also it helps us to achieve the right first time, which we call as reliable quality or quality 4.0. So not to forget, supply chain is another area which OEM is trying to embrace within this digital thread. And once they are in, so they give intuitive metrics of both leading and lagging time, so that it acts as a better handle for handling all the production schedules and also time to market, Samir.
Great insights as well. Luke, anything to add here based on what Vijay has said?
No, I think that was really rounded, so nothing to add. Thanks, Vijay.
All right, then Vijay, if I may stay with you, I mean, you mentioned data as well there. I mean, given the emphasis on data traceability and consistency across the product lifecycle, what role do you see digital threads play in improving, for instance, regulatory compliance, especially given quality metrics like right first time, right, and efficiency demands, for instance?
Yes. I also worked in pharmaceutical, so I understand regulatory and compliance very well. And A&D is nothing short of it. And A&D is aerospace and defense is very highly regulated industry for mandating compliances with regulatory bodies and governing by federal bodies like EASA, FAA, and other government bodies. So tighter the regulation, that forms the foundation for the customer confidence, and every one of us, the common man, we repose our complete faith in these regulations for assuring one's safety and reliability. A&D compliances, this requires a mammoth task of authoring, managing, and maintaining large amount of both product as well as the process data. And for this involves costly systems. It also involves skilled laborers who are aggregated to standards, and not to forget the complex processes so that we ensure the accuracy and also the traceability which you are mentioning. The solution is digital thread. So digital thread, as Nick explained, it can comply to all the regulations and bring in large amount of product data from cradle to grave. That can be easily managed, which is coming in from different systems, so that we can automate the compliance processes and the workflows. And so naturally we reduce manual interventions. This also provides a comprehensive view of data flow, so that there are digital trails with good timestamps, so that we could ensure traceability for inspections and audits whenever it is required and mandated. It also, and regularly within aerospace and defense, there is lots of change management happening. So this can effectively manage and address those changes, either it is coming from design, manufacturing, or any other relevant services, so that the smooth operation within concurrent engineering can be done, and thereby we ensure the design intent is met and quality standards are also achieved. So there you go, you have faster compliances through automation, but also effectively utilize the product and the process data for manufacturability. Thereby, you have the right first time. So quality and compliance, safety are met through digital twins and digital thread, Samir.
Great, great, and appreciate that holistic view to it as well. But while we're speaking about that, Luke, if I may go to you here, and talk about the scalability potential. So how are companies ensuring scalability in such technologies like digital twin, digital threads, as they
Yeah,
expand across more diverse and complex sort of applications in A&D?
No, it's a really interesting question, Samir. And if I could, I just wanted to just come back on something Vijay was talking about with regulatory. And the only thing I would probably add there is that I think once we've got a range of individual assets modeled digitally, maintained in near real time, I also think rather than just complying with regulation, I think the insights that businesses, sectors, and globally cross-sector even get will actually start enhancing regulation. So I reflect, particularly from my large background in aero engines, this pivotal test called a type test, which modeled the conditions, certain time at takeoff, certain time at climb. And the reality is that 3, 4, 5 decades on, modern products and the environment they operate in aren't quite the same. So I think that intel will drive regulation forward as well. But back to your comment on scalability, and I think this is something that many businesses of many scales are really challenged with at the moment. And in some ways, some of the new incumbents and some of the smaller companies have got a benefit of being able to kind of adapt and respond more quickly than some of the large primes, the tier ones and the tier twos. And I think that's because to go backwards to drive your business, forward using the technology that Nick and Vijay have talked about can often bring a degree of significant retraining, a degree of significant investment. And so they're always thinking about when's the right time to invest, what systems, what products do they do it on. And in some ways that can lead in big companies to a degree of old company and new company under the same kind of logo and banner. But there's a few themes that I have seen, both from my experiences in aerospace and defense, but also with some of the clients I'm working with now. The first thing I would say would be there's a theme around organization, and the businesses that are doing really well on this have identified the need to make individual people accountable for the capability and the transformation journey. So we're seeing some of our Quest clients actually now appointing chief engineers of this digital capability. The title may vary, but they're appointing somebody with a appropriate competence to manage the strategic capability. The second thing I would say is that we're starting to see the companies doing well at this invest in their technical skill sets. Some of that can be upgrading the systems engineering experience, but the ones that are doing it really well are also making sure that the design engineers understand more about Vijay's world in digital manufacturing capability and vice versa. We're seeing some businesses understand their supply chain and what the supply chain needs from design and manufacturing. And so you're seeing that cross-discipline and cross-functional skill set develop. And then there's a few other, I'd say, more left-brain logical things that the best companies are doing. Standards and modular architectures starting to emerge. So companies can actually start taking a similar approach across different product lines, different systems, sometimes even in different sectors, but the company has a standard way of operating. And to enable of that, you're starting to see people become far more focused, controlled and governing of the data and the data frameworks that are being managed within the business. And I think that's giving them a real strong platform for growth. And then probably just to finish off, I would say there's a degree of cross-sector learning we're all seeing. And, and I can share this because it's in the public domain, but I was really impressed with some of my really clever colleagues in BAE Systems in the air sector, who a lot of their business is aimed at driving training, whether that be driving maintainers, fast jet pilots, and so on. And they took a really bold but a creative decision about 5 years ago to start working with partners within the gaming industry. And you can now see where they're going now. The synthetic environments that they're creating, reinforced by the digital twins, simulators and synthetics they've got, but learning from the different sectors is really helping them to kind of spring forward. So I'd finish off with saying collaboration in all its forms, internally across disciplines, engineering to manufacturing, to finance to commercial, but also with your partners and your supply chain is also bringing great insight, as long as you stay true to that focus on investing in people and the resources that the business needs to do this.
Absolutely, then that makes a lot of sense. Nick, if I can bring you here, following on what Luke just explained, in what ways do you see digital twins providing a competitive advantage? I mean, we see the increasing complexity of aerospace and defense products in recent years. So how does digital twins and digital threads ensure system reliability while shortening, say, design cycles and reducing time to market?
Yeah, I mean, so yeah, exactly. So thank you. Just to touch on a few of the points that the others have already made. As Luke mentioned, right, so if we just step back a second, some of the really big macro trends, I think you've just mentioned, right? But if you look at traditionally, most very large, complex aerospace and defense programs over the last 15 years have all experienced some sort of challenge, often from a delivery, time, cost, quality perspective, right? And often all three. Often in all three for very different factors, very different elements. And often, delivery has been many years later than the original plan. And as Luke mentioned, one of the other macro trends here is that actually, the needs and the threats, depending on which environment you're talking about, are evolving extremely rapidly, and the world is changing very rapidly. And in many ways, the A&D sector almost needs to kind of adapt and kind of come on speed with that trend of the way the rest of the world is evolving. There are some elements, for instance, in some of our other verticals in say the high-tech sector or the silicon sector, where actually we see some of the mechanisms or ways of working in some of those other sectors, which are difficult to translate into highly regulated environments such as R&D. But actually, that doesn't mean it's not critical that we crack that conundrum. Because ultimately, we're faced with all these different challenges. And piled on top of that, there's now very much a finite resource. As most of you will work in most of the Western world, we've got a stage where most major A&D customers are short of resource, and there's just a finite capability of skilled, capable engineers in the right place to do the job. Right? So the only way to solve all of these conundrums is actually start looking at not just the fundamentals of, okay, how many more people can we develop, but the fundamentals of how we do engineering. How can we do engineering more effectively within a highly regulated environment such as A&D? And that does require some significant investment, and therefore some significant openness to evolving and continue developing our mechanisms and ways of working. Probably not in a way which, fundamentally for the last 15 years of most of my A&D career, fundamentally how we do engineering has been relatively static within the domain. And I think there's going to be a big leap in evolution going forward, particularly over the next 5 years, as we move into this. So ultimately, the competitive advantage is all around the time and cost element of time, cost, quality. So what does that mean? That means fundamentally left shifting your development risk. So, most major programs people would have been involved in, they would have found that there's, quite significant challenges have been discovered right at the back end of the program, often many, many years after core development. Obviously, the cost curve of those things is exponential as you shift further right into the program. And you've often de-skilled the team at that point. You've often got some, you have different people working on the problem. So it becomes harder and harder to resolve those issues the further left you find them. We need to improve our, right first time. There are some good metrics out there around, within a traditional A&D program, the amount of effort it was required in the kind of integration, de-risking, trials, tests, commissioning phase versus the science development age. And it's often disproportionately weighted to that back end. And often people find that the lag on programs is disproportionately shifted to the back end. So what people think is going to be a 2-year, development integration phase ends up being a 5-6 year phase as all of these challenges ironed out. So absolutely fundamental is to, and then latterly, the kind of that time cost element, I guess the quality element. There's been many instances in major programs where we've had different problems from different iterations of systems across different elements. And many of those challenges are, often each individual team or system that's doing their chunk of the work is doing it in an effective, efficient manner. But often some of the information is lost or translated, and some of the issues arise where what we used to call the baton is passed between functions or systems. So it's the interconnection between either business into business functions, or the systems which often relate to those functions as you move from requirements to design, or design into manufacture, or manufacture into sustainability. And obviously, there's so many different data flows and data exchanges within that whole environment that unless you can have a digitized, centralized, single version of the truth, the room for errors creeping in, which ultimately results in rework and less and reduced right for time, is almost exponential. There's almost infinite possibilities of challenge, which is I think what we've seen in most large A&D customers. So I'd say to sum up, ultimately this is about kind of left shifting our ability to identify issues in the design earlier, to make one integrated, I guess, holistic joined up elements, which then drives efficiency and improves right first time. And that's ultimately and the companies that can get on top of this major revolution in how we do engineering, I think, are going to be the A&D companies which emerge from the next 5 years as the market leaders in that field.
Thank you, Nick. I mean, could you maybe share some examples from your projects at Quest Global? Maybe Vijay, I can bring you in at this point. Any examples you could share related to what Nick just explained?
Yeah, sure. So I see a slightly different way, and just to complement and supplement what Nick told. See, for us, every customer is important to us, and each one of them has their own USP. So customers, we become the flag bearers of these new technologies coming in, and when we try to showcase this without again infringing on the IPs of one another, we see customers who are ready to embrace and invest the digital transformations toolkits like the digital thread and the digital twin. They reap the benefits faster. Yeah. So for us, the journey begins by assessing their digital maturity of their current standards, and we help build that gap analysis and reason that with right production solutions so that we could implement sprints and then scale it to the wider scope, and thereby we realize the return on investments. For a few examples I could quote here. One is we have helped customers to reduce their non-conformance and improve their right first time from 67% to 95% for a forging company here. Along with our partners, again, we have helped a US automotive company implement zero downtime by implementing predictive maintenance. We had a very good partner in Israel who helped us and understand the machine learning algorithms. Thereby, we embraced that to improve the process capability index for manufacturing of an auto part from 0.67 to 3, which is like a 12 sigma. That particular project became a framework for our zero defect template. And also we have been developing AI solutions where we could develop those kind of templates to detect anomalies between weld or in adhesive defects and thereby reduce the scrap rate by nearly around 5 to 8%, and also have given back an annual savings of $1 million for a company in US. So some of the examples which I could reflect back from our team here, Samir.
Really impressive examples there, Vijay. And now, before I move on, just a reminder to the audience: if you have any questions or comments, please do add them in the chat in the Q&A section. I already can see some questions being asked there, so we'll get to them by the end of the discussion. But Luke, if I can bring you here into this topic, and could you maybe give us a bit of a higher level sort of industry perspective to what Vijay and Nick just covered, basically?
Yeah, I mean, I think they've covered the major themes, but I think the things that particularly resonated for me would be, Nick described it as kind of left shifting the product development life cycle, which I absolutely kind of endorse and support. But I think the fact that you've just heard that, the two experts talk there as well, I thought would also highlight that importance of the world is no longer going to be as siloed in most modern businesses. So that doesn't mean that we'll, smash together engineering and manufacturing, necessarily, but the way they operate together I think is increasingly going to be fused and using that one source of the truth. In fact, I'll go further and say that one model of the truth that kind of Nick was referring to. I think for me, one of the phrases that always resonated when I first, kind of came across the phrase of digital twins was the fact that it gave us the ability to kind of fail often, frequently, and early, but often being able to fail in a virtual world rather than, what used to be at the start of my career, we would commit to several £1 million worth of tooling for new blades, new casings. We would get some feedback. We'd have to go and modify it, wait another 52 weeks for your tooling to arrive, try again. Maybe you got it right. Maybe you needed a third iteration. I mean, these were, even 30 years ago, double figure millions decisions, and each iteration could quite easily be 52 weeks. I mean, that just blows the business case for many of the programs that exist in civil aerospace. In a defense context, it can be even worse because that means that you may not be competitive, in the contested space that you're defending for an unacceptable period. And so I think, the urgency is so much around there. So really echo that left shifting. I also think one of the elements that we did touch on lightly before, which I think is going to be a major area for us, is that enablement from the digital twins and the digital backbone into the world of digital certification and clearance. And whilst we always need to make sure, for all the right reasons, that we have real clear independence between our regulatory authorities, our internal, I would say, safety and airworthiness advisors, the quality organization, then your engineers and your manufacturers, independence is needed. But I think the days of operating two different models with different messages between the groups, sometimes adding in weeks and months when things are changing day by day, minute by minute, it can only lead to a safer as well as a more efficient, maybe a more sustainable solution. And so I wanted to kind of put a big shout out there for the product integrity and safety aspects of what we're doing here, because we're all consumers as well as engineers and business leaders as well. So I think there's some real societal impacts that could come from this. And that probably just leads me on to my kind of last reflections there, which is particularly around that life cycle management element. I think we've touched it several times during the conversation, but I think moving into that model-based world and model-based way of thinking, I could see the best businesses now, and certainly all future businesses, being far more dynamic and questioning themselves and their decisions around a model rather than a deck of PowerPoint slides, to try and help them kind of assess that information. And I think that naturally will just take the cultures of those businesses and the leaders leading them into a different place for where we are now. So I think we'll just have the tools, the ability, but also that shifted mindset to be forever wanting to improve, to enhance, and checking that the assumptions that we made yesterday's decision on are still valid based on the fact we've got some real-time models from the assets that are out there.
Yeah, thank you for that, Luke. Really helpful. Vijay, following your examples that you mentioned, is there a specific project that you'd like to share where maybe digital twins and digital threads have sort of enabled some significant improvement in manufacturing processes? How have these tools helped transform such a project from start to finish there?
Yeah, definitely. So again, in continuation to what Luke told about scalability and modular certifications, so we partnered with Siemens. Siemens has a beautiful toolkit which has a 360-degree factory environment which can be replicated virtually. So we invested in that in our facility in Bangalore. And that particular facility, we could mimic every bit of manufacturing. Again, not to forget the left-hand side, what Nick was suggesting. Design, again and again, I stress on this, design for manufacturability, the DFM became the backbone. And that was our biggest learning, because again, we failed fast. We understood the failures, and we failed fast, and we adopted the design for manufacturability, Samir. And in the case study which we have shared, what we did was we kind of adopted the model-based definition. Again, everybody adopts model-based definition. It is only useful when it is been structured and architected with design for manufacturability. In this case, everybody speaks again on efficiency and productivity, etc., and they give some numbers. So we wanted to really test this, and hence our customer gave us a neutral product, a test case, wherein what we did was we had two dedicated teams. One team worked on a digital practice, and one team worked with the traditional practice for the complete product life manufacturing engineering life cycle, what is being mentioned on the x-axis. And you could see vast difference and the influences of the way how we done it in the programs, machining, and with automations for the inspections with the NX, and also did a lot of automations within the technical instructions and animated those so that it could be easily understood and manufactured down the line at the shop floor. And this particular case study proves that nearly 40 to 45% of productivity and efficiency improvement is there if the customers or the world adopts the digital way of manufacturing. Samir.
All right. Thank you, Vijay, for that. Luke, if I can bring you in, but very briefly for the sake of time, anything you'd like to add here to other examples if you have in mind?
No, I think that's fine. Conscious of the time, if that's okay, Samir, I'm happy with that.
Then let's do that. But I'll stay with you, Luke, because I mean you've talked briefly early on about the challenges, right? And I'd like to dig a little deeper into this. So the idea of a continuous data flow across a product lifecycle is central, as we know, to digital thread technology. So what challenges, I mean, following on what you said earlier, what challenges do you see A&D companies facing when integrating digital threads? And how can they overcome these obstacles?
Yeah, so some we've kind of touched on along the way, but it is worth touching back on them. So I'm going to start with one which I'd probably phrase as data integration. And one of the common themes across aerospace and defense is that the products and systems and services that we support are often multi-decade. In fact, some of the aerospace systems that are out there, I can think of the B-52, for example, that will be a century, that will be 100 years in service in one form or another. So those very long cycles mean that we actually have quite a lot of legacy platforms and services, and sometimes legacy skill sets in the business that we kind of have to manage. And so I think one of the major challenges there is how do you manage those legacy platforms that still might have 40, 50 years ahead of you? But internally, it's always quite a difficult and challenging business decision to invest, to digitalize, to develop those definitive, verified and validated models. So data integration would be one. I would also say within data integration, traditionally, many aerospace and defense companies have been very delineated by function or discipline. We talked about engineering, manufacturing and supply chain. And so we have to be able to leverage the abilities that the backbone gives us that Nick's mentioned to help bring the functions closer together, align them on goals, objectives, as well as that common source of truth. Cost of implementation, I think, goes with some of that. So there's some great capability out there. Traditionally, engaging some of the players with these great tools can be, again, a double-figure millions kind of investment for businesses. My slight frustration is that most of the A&D businesses will invest in the infrastructure and the tool set, but aren't quite so willing to invest in cleansing and getting the data that it's built on in a verified and validated format. So there's a little bit of mindset in the mix there. I would also say that sometimes, particularly in defense, the programs that we operate on, for all the right reasons, because they're often government-to-government programs and they're funded ultimately with public money, there is a degree of kind of commercial constraint and bureaucracy that goes around the programs. And so I also think that we're going to have to, over time, make sure that those modern businesses enable themselves through the programs and the frameworks that they operate in. Cybersecurity, I think we touched on briefly earlier, but I would say there's the security side of things, but there's also the intellectual property management and the export control, particularly when we're dealing in these programs. Often, as I've mentioned, in defence, invariably government to government, so you're going across national borders. But even in the civil aerospace world, this is such a global connected supply chain that we're dealing across borders. So you've got to be managed within the program constraints, but also what you can legally do on the export and control of information. But what I'd say is these are all challenges, they're not blockers. And all too often, I will hear people talk about what they can't do rather than actually understanding how they could get themselves to an enabled position. So some of the work that we've done in Quest has particularly been focused on helping our clients go backwards, cleanse their data, partition it, such that they can then move forward with a kind of a clean foundation. And then lastly, I would say to help them scale, to help them get into this space, it really needs leadership to invest in themselves. And I include myself in this. I'm still on a learning journey. I'm sure many on the call are when it comes to digital twins and digital backbone. But we do need our leaders in these sectors to be forever sharpening their saw, to learn, to understand, such that they're able to kind of lead and enable the technical teams to drive this forward. So we need some courage in leadership as well, Samir.
Absolutely, absolutely. I mean, this conversation can go really long. I'm really enjoying these answers. So, for the sake of time, I'm gonna end with you, Vijay, with a good question about sustainability, if I may. So, how are digital twins and digital thread technologies, as you see, helping A&D manufacturers, say, reduce waste, improve resource efficiency, or I mean, meet environmental goals in general? Vijay, you're muted. There you go.
Yeah. So there are various surveys, but A&D, it kind of falls under low to medium contributors, especially for the carbon emission, unlike other, I would call as offenders like consumers, construction, electrical, electronics, and transportation industries. But still, A&D customers worldwide, they have been committed for a cleaner and greener environment. They are pledged to reduce the greenhouse gas emissions to 30 to 40% in a decade or two. One of the foremost key advantage of digital twin and digital thread, as Luke and Nick alluded to, is to improve the efficiency and productivity. Again, the QCD. But QCD, it's a function of time, labor, material, methods, logistics. So any reductions there is quite meaningful, right? So this directly reduces the carbon footprint in all the framework of sustainability in scope 1, scope 2, and 3. Again, not to forget, as Luke alluded to, that catch the error while before it happens. That's where that robust simulations of the digital twin and also the real-time data coming in from the digital thread. This reduce the both time to make as well as time to market. Thereby, products are produced faster. They also conforms to the accurately to the designed intent, and thereby scrap and repairs are also avoided, thereby reducing the carbon footprint. Predictive maintenance of aircrafts, of engines, or for that matter, the machines which produce these A&D parts, they promote prescriptive visual dashboards for quicker analysis and also effective resolutions, which in turn helps us to save energy and thereby reduce carbon footprint. So both the digital twin and the digital thread, they play a major role for once the supply chains are connected to, with the OEMs, so that they can provide real insights on the inventory stock, which could be and also be traceable and also improve the logistics, etc. So also the leading and lagging metrics can be effectively utilized and they produce only what they need and eventually reduce the landfills. So these are all the direct influence in reduction of carbon footprint. Last but not the least, paperless. Going paperless. So paperless factories and paperless manufacturing is another great initiative encompassing both digital thread and digital twin, aiming zero paper trails. So there is substantially reduce the carbon footprint and achieve sustainability. And we are helping our partner manufacturing company implement this in Belgaum, in Karnataka, India, for achieving this paperless manufacturing. Samir. So these are the 4 things which I could think about on how A&D and digital twin and digital thread are aiding the A&D sustainability journey.
Really impressive stuff. Thank you, Vijay, and thank you all for this really, really insightful discussion. I learned a lot, and I'm sure a lot of the audience has as well. We still have a little less than 12 minutes to finish this, so I suggest we go straight to Q&A and allow people to bring in some questions that they have to the panel. But thank you so much for sharing your insights so far. Let's have a look at the questions that we've had. There's one question that says, while I'm aware of digital twins in the design and manufacturing stages of a product lifecycle, are there any good examples of digital twin in the in-service phase, so like performance twin? And the question is to the panel, whoever would like to answer.
Yeah, so I'll give a reflection, and I won't share the company if that's okay. But I guess in the aero engine sector, in fact, most of the large players, so you could probably infer who I'm talking about, do have a range of capabilities where they are constantly feeding back performance information, sometimes near real time whilst in flight, into digital models. And in particular, what they're doing is they're learning the deterioration characteristics of the products and feeding that forward. And whilst there's still room to kind of continue to optimize for the next iteration of the design of that propulsion system, the really important things that this can lead to is also helping you on your airworthiness management. So trying to decide how long you could leave a product on wing before the deterioration is unacceptable and needs to come off. That then has a flow down into the initial provisioning, or the spares, let's call them spares, that you need to put into the network. So the demand on the supply chain, as the confidence levels grow, and confidence is a really important theme there in digital twins. As the confidence level grows, that might help a business reduce the amount of inventory, to Vijay's point, it needs on the shelf. It might mean that for an airline, for example, that you don't have to have every one of your support bases to have all the same provision of equipment. Now, it can also lead to a fact, and we didn't talk about so much about fleet management, but if I stick with the aero engine example there, if you've got the right industry agreements and you've got all of that standardization and modular approach, then these digital twins you can almost take into a meta model of the whole flying fleet, not just within one airline, but globally across sometimes even competitor airlines. And sometimes you can see benefits to all of them by helping competitors work together in the same space. So I can think of examples where there's been an issue, for example, a gearbox failure on an engine, and with the right insight, the right deterioration models, and with the right relationships, actually even competitors will help themselves to keep a service available for the good of the industry. So there's all kinds of levels once you get that surety confidence going up. But absolutely, real live examples of what's happening later in the life cycle are making a difference right now, safety and the economics.
Thank you for that answer, Luke. Really, really helpful. Another question, maybe Nick, I can come to you on this. How does Quest Global ensure the digital thread solutions remain adaptable to future advancements in aerospace manufacturing?
Yeah, thank you, Samir. I think the key there is that very much our digital thread framework and architectures we've developed, we've tried to be, where possible, and it's not always possible, but where feasible, to be either domain or tool agnostic. So rather than developing a digital thread for a particular use case, with a particular it's highly integrated with a particular one thing or tool chain in mind. Ultimately, we recognise, as I mentioned earlier, this is a never done evolution. So you're always going to have efficiency enablers throughout the digital thread, and the level of integration, as Luke mentioned earlier, is going to enhance as you progress. And ultimately, that's going to generate new challenges as you bring new automation into the process. So ultimately, we've developed a kind of broad holistic framework by which we develop and help clients kind of map their current digital thread status, map their future state, and then evolve their gap analysis to bridge that gap. And that's very much based on a set of modular frameworks, which, as we say, try and look for, you know, what do you need to be in 5 or 10 years' time as where you are today. So I think keeping your digital thread solutions flexible, dynamic, not building, you know, bespoke solutions around a particular thing, which, you know, I think many clients have come across, say in the so to example of, you know, many clients in my previous life where I had a, you know, highly bespoke ERP solutions, for example, seemed great at the time, built around a very specific business process that particular customer wants. They find that 5 years down the line, actually, when they come to actually maintain and sustain those capabilities, it becomes increasingly hard as you develop through time. So, you know, in the digital thread evolution of that's one microcosm of an example within the digital thread. And most clients are now actually going back to, actually, let's take something more vanilla, let's make something which is more workable, let's try and adopt open interfaces, and let's try and define a common data backbone across the digital thread such that it is adaptable, flexible. Because the only thing we know about the future is it's going to be different, and there are going to be new challenges, and we're going to need to change things. But we don't yet know what that looks like.
Yes. Thank you for that, Nick. I have a question here, basically for the whole panel, which is really interesting, and it aligns with what Luke was talking about earlier in the conversation. Where they ask, how does the panel see cultural resistance or change management for replacing manual processes with tools like, you know, digital threads and all that digitalization that we're seeing?
Yeah, well, so quite often whenever new technology comes in, there is always apprehensions within a community. And I, being a manufacturing engineer and worked in traditional manufacturing, I know the nitty-gritties, what happens within the shop floor whenever you bring in automations, etc. But customers are, I have seen customers being really, really smart. Especially when we adopt digital manufacturing and digital technologies, they perform the demonstration to appease and lower the apprehensions of people where they feel they'll be replaced. But it only improves and upskills them. It improves the way they do, the feel they get. And they themselves will be wowed. Whoever are giving apprehensions, they themselves will be wowed by the technology and how he or she can be more productive by embracing this, and how safety is inculcated in these technologies, especially in case of oil and gas, and where hazardous manufacturing is happening, how digital technologies are helping them, etc. So answer is yes, there will be that initial glitch, but slowly they overcome by once they understand how great these technologies can impart their life.
I think just to build on what Vijay said, I think one of the really nice spots about what the industry is today is that, you know, traditionally people might be worried about, oh, hang a minute, you know, that's new mechanisms going to be more efficient. There's going to be less work for us to do as a collective. You know, there's so much demand and there's so much challenge out there in the ANSP space that, you know, the days when someone is worried about the fact that there might not be demand for their skills anymore are, you know, almost, that's, you know, a concern that's on nobody's radar in the kind of who has a window of the broader visibility, right? So, you know, ultimately we see this as a way of enabling engineers to do higher valued, more value add, ultimately more work which they can see direct correlation to output from. And it should free up teams in order to do work which we just couldn't do before, because many companies are looking at work going, I can't do all this, I just don't have the bandwidth to do all this work. Therefore, there's interesting, you know, work which ultimately we're having to pass people by. So I think it's really important that it's sold to organizations in the right way. I think people identifying the right change agents within their organization to help sell that benefit, because they'll always be reluctant, right? Change is difficult and change is hard. And, you know, I'm sure everyone's been through the kind of change management stuff. But I think actually just where the industry is today, where it's probably an easier sell today than it's ever been, because of all the challenges we've articulated, and particularly as Luke mentioned earlier.
And Samir, can I just follow up on those comments? I fully agree with my colleagues there. I would give a positive vote for this. I would say certainly for those in early and mid-career, I was struggling to retain engineers and manufacturing engineers when we were stuck in the traditional world. So I think increasingly some of these technologies will help the employee value proposition and may help us kind of attract and retain. But then I'd also finish up by saying Dan Pink, I don't know if any of the people online have ever followed any of Dan Pink's work, where he looks at what kind of drives and motivates people. And in a nutshell, there's a great video online, but it always stuck with me. There's three things that motivate all of us normally: autonomy, mastery, and purpose. And I actually think digital twins and the backbone connectivity helps on all three of those. Autonomy, because you've got a single source of truth, it's real, it's in line, so you've got all of that opportunity to kind of be master of your own kind of destiny on the information you've got. Mastery, because you can decide how much you invest, how much you use, how it's scalable. And purpose, because I think there's that clearer lens to the end customer and the end society that's using our product. So I think this could be positive. There's just a little bit of help we need to do on those in my age group, later career, trained in traditional approaches, to help them see some of the changes. But besides that, I see it more positive than negative.
Absolutely. I mean, it's a matter of clarity, right? For people to really see it and to see the benefits in it. And even if it takes a bit of time, there's always a certain threshold that people tend to get over and really understand how these technologies are impacting their way of work and their industry in general. I'd love us to have more questions, but for the sake of time and being mindful of everybody's time, I'll end it here. If we couldn't manage to answer your questions live, fear not, we'll make sure that the panel gets your questions and they can check them out offline and get back to you. But for now, I'd like to first thank the panel for your time and for your amazing insights and then really great experience that you shared with us today. So thank you to you, Nick, BJ, Luke, appreciate it. And and thank you so much for our audience as well for being around with us. It's been a pleasure to have you all, and we really hope that you've got exactly what you needed from this webinar. And I'm sure we'll have more of these coming to you very soon. So thank you for joining us, and we'll see you in the next one.
Thank you for having us. Bye.
So